Now let's take a look at the MITRE attack model as it plays out in a demo attack run on Chaos, offensive command and control platform. Here we have the MITRE attack matrix that we already discussed, and we'll follow the attacker as they launch their attack. In this example, we'll be looking at an APT, Advanced Persistent Threat, in which the attacker gains initial access by sending a spear phishing email to deliver ransomware, a form of malware designed for the sole purpose of extorting money from victims. The email contains a malicious attachment to infect an employee's machine, and the attacker then uses the malware to access sensitive information. This is the attacker command and control server as it appears in Chaos. In real life, the attacker will have a similar setup. The attacker selects phishing email from their list of exploitations. They then send the malicious email using a source address that makes it look like it came from within the organization. In the black box here, we see the command that is responsible for sending out the spoof email. The next step is execution. Our attacker wants the user to execute the attack. They rely on specific actions being taken by the user in order to execute the malware. To make sure the user does what is required, the attacker subjects them to social engineering, a kind of psychological manipulation that gets them to perform a certain action. In this case, using an innocent-looking document attachment. Meanwhile, the attack victim is at their device. They log into their email account, access their mailbox, and open the file attached to the email, in this case a PDF. Here we see the PowerShell window that has been triggered by opening the PDF. This is how the malware is downloaded and executed on the machine. Opening the Process Explorer tool on the victim's computer, we can see the download and execution of the malware process that is happening behind the scenes as they opened the PDF attachment. The PDF file exploits a vulnerability in the PDF reader software that allows it to download and execute the malware. Back at the attacker's command and control server, a new session has been created, indicating that the employee's machine is now being controlled by the attacker. Initial access has been granted, and the attack has been executed. Now for the persistent step. The malware has attached itself to the apps that run automatically when the machine is started up. This ensures that the attacker will still have control over the machine even if it is rebooted. In addition, the attacker creates a new user account as a backup, as we're about to see. Opening the user account list on the victim's machine, we see the users listed before a new user was created. Here we see the current users. Back at the attacker's command and control server, the attacker sends a command to create a new user account. A quick refresh in the device user list, and we see the newly created user account on the victim's machine. Meanwhile, in the background, privilege escalation is run. The attacker now has access to a valid account. For the defense evasion phase, built-in functionality of the malware obfuscates files, hiding artifacts of the intrusion from analysis to evade detection. The defenses of the device are also impaired by disabling the antivirus software. Here we can see the antivirus status before it is disabled. It is on. The attacker sends the delete antivirus command to the victim's machine. Now, when we check the status of the antivirus, we see that real-time protection has been disabled. A quick check of the system settings shows that it cannot be enabled. The attacker on their side starts a listener on a second malware command and control server and waits for the victim to connect. In this case, the attacker uses a known remote access Trojan malware that should be detected by antivirus software. But our victim's antivirus software has been disabled. A new session is created for the infected machine on the second command and control server. Here we see the command and control of the second malware on the attacker's server. Next, the attacker wants to obtain additional credentials to expand their capabilities. They use a tool that extracts credentials stored in the operating system. From their command and control server, the attacker deploys a tool for finding usernames and passwords on the victim's computer. The results are sent back to the command and control server, and new usernames appear in the history. Mimikatz is used to extract credentials from the operating system. Next, the discovery stage. The attacker wants to spread within the organization, so they use network service scanning to map the internal network. The attacker activates the internal network scanner from the command and control server. The network mapping shows the attacker more devices and systems that they can use for their next attack. The results, the computer's IP addresses and open ports, are sent back to the command and control center. Next, for the lateral movement stage, the attacker uses remote services to spread and infect more machines. The attacker selects a WMI worm from the attack options in the command and control server. The worm works by replicating itself in order to spread to other computers and servers on the network that are using the WMI service. As each new machine is infected, a new session is created in the session list. Now for each machine, the attacker can send attacks and collect information on the victim's computers. Now that access to the system has been established, the attacker can get to the sensitive information that they have come for. They do this by collecting screen captures. The malware in this APT uses HTTP application layer protocol for communications and for file and data transfers. The attacker steals data by exfiltrating it over an existing command and control channel. Stolen data is encoded into the normal communications channel using the same protocol as the command and control communications. The attacker sends the take screenshot command from their command and control server. The results arrive back at the command and control server. Here's the screenshot. Now reach the impact stage. Once the attacker has access to enough machines, they are ready for their last attack. Data on the target systems is encrypted to interrupt system availability and network resources. The attacker attempts to render stored data inaccessible by encrypting files or data on local and remote drives. The attacker may also launch an Endpoint Denial of Service (DOS) attack to degrade or block the availability of services to users. Endpoint DOS can be performed by exhausting the system resources those services are hosted on, or exploiting the system to cause a persistent crash condition. To achieve data encryption and endpoint denial of service back at the command and control server, the attacker goes into Attacks, selects the devices they want to attack and which attack they want to use, in this case, ransomware. The attacker sends the ransomware attack from the command and control server to all infected machines. On the infected machine, the victim is innocently logged on, unaware of everything that's been going on behind the scenes, until they are notified that their computer has been hacked, and the ransom demand is made. All the files have been encrypted, and the victim must pay 200 Bitcoin within 24 hours to get the decryption code to retrieve them. So, in this APT demo, we have shown the various steps involved in a common phishing and ransomware attack, one of the most rampant forms of cybercrime in recent years, used to target the vast majority of organizations.